Hey guys, just got this in. This is a 12.8 volt, 460 amp hour lithium iron phosphate battery from Temgot. That's over 5,800 watt hours of stored energy. It is built in a strong heavy duty steel case and is rated for up to 250 amps continuous charge and discharge current. I haven't looked inside yet, but I already ran the capacity test, and if the inside is built as well as the capacity test performed, I think we'll have a real winner here. Let's take a look at those specifications. I'll show you the capacity test, then we'll tear it down and see how it's built inside. This battery measures 18 inches across, 10.6 inches in height, and 10.1 inches in depth, and it weighs in at a solid 100 pounds. As mentioned, this is a heavy-duty steel enclosure. There are two collapsible handles on the top for moving it around, though with this weighing in at 100 pounds, I would suggest moving it around with two people. Also seen on the top here, we have our display. It is completely discharged currently after running my capacity test here. Page 2, we have controls for the discharge and the charge FETs. We can see our capacity is 460 amp hours and it's been cycled 2 times, and there's some thermal information. We can see the voltages of each of the individual cells. This is a 12.8 volt battery, so that's 4 cells in series there. The lid appears to be held on by a series of Phillips screws the whole way around the case. Taking a look at the side of the battery, we have our main negative and our main positive. These are M8 bolts. They're very standard bolts. We've seen on pretty much all of the batteries at this point. They are the post style that stick off the battery quite a bit, you can see there. It did come with these terminal covers here, which are supposed to slide over the terminals, though to be honest, they don't really hold on very well. And then we have a sticker with some warning information there. And lastly, we have a vent here. This is something we haven't seen on many batteries. We have seen it on a few, but most do not have it. And that is just a pressure release. Should the inside of the battery become pressurized for any reason, you don't want it to blow up in a sense there, you have a valve to release pressure. Taking a look at our user's manual here, it's all very standard information. The first thing we want to touch on are the specifications. As mentioned already, it's 460 amp hours, 12.8 volts, 5,888 watt hours. Your continuous charge and discharge is 250 amps. Recommended charge is 92 amps based on a 0.2 C rate. And then we have our thermal parameters here. This does have low temperature charge protection, which should engage at 0 degrees Celsius plus or minus 4 degrees. You can wire 4 of these batteries together in series for a 48 volt system. We have our depth of discharge graph, and once again here, this battery is rated for 2,000 cycles at a 100% depth of discharge. And I don't quite understand why that is. Other batteries we've looked at have been rated for 4,000 cycles, and this is the second one now that has a rating of 2,000 cycles. And I see there's a page here for app instructions. I didn't realize this battery had Bluetooth. And look at that, I was able to connect to it with the Overkill Solar BMS app. I didn't realize this had Bluetooth, so let's take a look at the settings that are programmed into it. It's programmed to balance at 3.3 volts when there's a differential of 15 millivolts between cells. And the balance when charging switch is off. That's good. That means it'll balance all the time, not just when there's a charger connected. So low temperature charge protection is set for 0 degrees Celsius. Over voltage is set for 3.75 volts and under voltage is set for 2.2 volts. So I'm perfectly satisfied with all of the parameters I am seeing here. Alright, so I charged this battery up using my Ames 12 volt lithium iron phosphate rated charger. It charges at approximately 70 amps or so. And then it did sit on the charger overnight. Taking a look at the BMS display here, we can see it is reporting 100% full. And if I press on, is it page 3, we can see the voltages of each individual cell, and they're all pretty much within balance there at 3.5 or so volts. So I have the usual capacity test set up. It's a Batrium BMS with a shunt for metering, and then it goes out to a reliable electric converter here. This is the 3000 watt model, and it's connected to my Android tablet here, showing us voltage, amperage, wattage, and then discharged amp hours and discharged watt hours. The test load will be this Lasco space heater here, and I do have it set on high, which should pull, I'm hoping, around 100 amps or so. So here we go. Looks like we're sitting around 115 amps or so there, so we'll just leave this run until the BMS shuts down our test, then we'll see what our reported capacity is. "481 amp hours." That is over 21 amp hours above the rated capacity of this battery. 481 amp hours out of a 460 amp hour battery. That battery was near perfectly balanced at the top, and it was perfectly balanced near the bottom. That's how a battery should be functioning when it's brand new with matched cells. Now, unfortunately, because it was balanced so well, we didn't hit the low voltage disconnect of the BMS because the inverter had shut down first. And that's one reason I liked the old Bestech inverter, even though it wasn't built very well, because it allowed me to do capacity tests down to about 9.5 or 9 volts. But regardless, even with it shutting off early, we still pulled 21 amp hours over the rated capacity. That's incredible. All right, now the fun part. There's our display communications cable there. We'll just disconnect that. Here's a first look at the inside before I start pulling stuff out. We can see our BMS dongle is taped right in the front there. And then we've got our main negative going down to the BMS. That might be a JBD BMS down in there. We've got our main positive. And we have a plastic protector plate here with 4 more screws that we need to remove. And there we go. Here is the battery. So this is the communications cable that went to the front display. We have 8 cells in here. They're going to be 230 amp hour cells. We have some nice thick aluminum bus bars connecting them all together at all points. It looks like we've got some nylon lock nuts on there. And these are going to be the balance leads. They are crimped on with ring terminals and heat shrink protected, screwed down to the bus bar in a place that's not on the terminal, so there's a separately drilled hole. You can see an example of that threaded hole up here. And then there's some red stuff, it's like red hard stuff, holding that in place. And that actually looks very similar to how Vatmer did the balance leads in their battery. So I wonder if these two companies are related somehow. The balance leads are all nicely routed down the center of the battery. They're held in place. Look at that, it's actually held in place. Straight down to the front, it's held in place here again. We have 2 black leads on this one. What is up with the 2? There's 2 red leads here too. One of those must be power for the BMS, and the other lead is probably going to be the voltage sense leads. I see in the lower left corner here we have a piece of tape that's actually loose. That is holding down 2 temperature sensors. So we've got a temperature sensor located there, and we've got a temperature sensor located over here. Got to be very careful lifting these guys up since there's so much exposed conductor here. The bottom of the support bar has holes cut in for the vents, and there's a nice thick piece of foam padding sitting between the support bar and the cell. Alright guys, and these are Eve cells. They are model LF230, and that's why they perform so well. Eve has a fantastic reputation for cells. So these are going to be fantastic, long-lasting cells. And now seeing that they're Eve cells, it surprises me that it only has a rating of 2,000 cycles. So let's take a look at the datasheet. According to the datasheet that I found, the LF230 is rated for 3,500 cycles or more at a 1C charge-discharge rate at a 25 degrees Celsius environmental temperature. So these should be good for significantly more than 2,000 cycles. I don't know why that graph in the manual says 2,000 cycles. I suspect it's a very generic chart that they've simply copy and pasted from another manual, but I can't be certain of that. I can only tell you what the manual says and what I see in the specification sheet for the LF230s. Here's a look at the balance lead screws. You can see that plastic stuff, the adhesive stuff. It is holding down pretty well, but it does come off in one chunk. The lock nuts are 10 millimeters, and they do have the nylon insert, and they are flat on the bottom. There's so much metal in here, just large pieces of metal, that it's making me a little nervous. Here is the aluminum bus bar. It's got a decent amount of mass to it. 250 amps, I really couldn't say just by looking at it here, but I don't really see why not. And we've got the Longwise bus bar here as well. Same thickness pretty much, just a different style. And I don't think I can pull just one of these cells out. I see that they are all held in by this front plate here. There's a series of Phillips screws holding that front plate into place. And they must have stuck the label here over the front screws. Once that is removed, it looks like the cells slide out in this direction, and that also gives us access to the BMS. So I think we're going to take off all of this stuff to take a look at what we have. Alright, so those 6 side screws are only holding in the BMS board, and you can see there's a separate piece of metal in there for the cell compartment. So that's actually welded on, so there's no way to open up that cell compartment, so to speak. The cells just have to come up as a pack or individually, I'm not sure. But this BMS board is actually still held on. It looks like there are more screws coming in from the bottom. Alright guys, I cannot get these cells to come loose, and Looking at this further, there's actually a piece of metal down the center here between these two packs. So this is like one casing and this is one casing, or partition, whatever you want to call it. There is neoprene foam, it looks like, between them, and I suspect they're sort of stuck together in addition to being stuck to this epoxy board on the edge. The whole pack is surrounded in epoxy board on all sides, which is good to see. There is foam between the epoxy board and the end plate here, good to see. And I think what they must have done is assembled this pack outside and then slid the whole thing down in. It may be glued on the bottom. I know the cells are definitely affixed together, and it looks like they may be affixed to the epoxy board in some locations. I don't know if that whole pack is down in there glued or not. I did tip it upside down a little bit and tapped it lightly. They wouldn't budge out. I didn't want to bang on it too hard and have the whole thing come crashing out. That said, there's really not much we can't see from the top here. These are genuine EVE cells. They appear to be, at least. There's foam between them. They're insulated from the casing, and they're well fixed in the casing. Fixed meaning they're held together to prevent any sort of natural expansion. The terminals are the standard laser welded pads. There's plenty of surface contact area. All of the bolts I've seen everywhere have been tightened down. They have marks on them indicating somebody has probably torqued them to some sort of specification. Here's the BMS. This is a JBD BMS. That explains why the Overkill Solar app worked for it. Taking a look at the label, it is model number SP04S060-S-K version 1.2, and it does have a stamping of 250 amps. And you can just tell when you look at these BMSs how well it's done with just the little bit of components you can see here and how cleanly soldered they are. It's not like some of the other BMSs, I'm not going to point out names, where it's just like components thrown together and there's lumps of solder and all kind of. Our battery cabling on the negative side is comprised of three 6-gauge conductors. It is silicone insulated cabling with a 200 degrees Celsius insulation rating. On the positive side here, we have a piece of number 2 or 2-gauge cable. 2-gauge, 200 degrees Celsius insulation rating. This standard silicone cable. I don't see any reason why these components could not push 250 amps charge and discharge, in my opinion. Even taking a look at these pass-through terminals, these have a lot of mass to them. That's got to be at least 1/4 of an inch or more there. All right, guys, so there is the Temgot 12.8 volt 460 amp hour battery. I really tried to find something I didn't like about this battery, and I've got nothing. The only thing I can think of that they might improve on are the plastic terminal covers that don't really latch on the side terminals. That's really it. Everything else in here is absolutely perfect as far as I'm concerned. These are EVE cells, the LF230s. They blew the capacity test out of the water at 481 or 42, I think it was, amp hours. So it was over 20 amp hours of the rated capacity. It's got a quality JBD BMS. It's got nice thick cabling. It's got a heavy duty steel enclosure. This battery sells for $1,083. It is shipped for free, and that includes a 5% discount code. You can find an affiliated link down in the video description along with that discount code. Now, I did go back to my VATWR video from 8 months or so ago, where I reviewed VATWR's 460 amp hour battery, and the insides of the battery are built very, very similar, especially the battery pack itself. There are some differences in the case, but the battery pack itself looks identical. The only difference I can note from that battery to this battery is that VATWR didn't test at the full 460 amp hours. Temgot tested at 481 amp hours. So there is a bit of suspicion there. I'm not quite sure what's going on, but I don't really want to speculate. But if you guys think I missed anything, please do let me know. If you end up buying one or you have one, please let me know your experience. The experiences you guys report back is valuable to me, and it's valuable to anybody else watching these videos who may be interested in buying a similar battery as well. Otherwise, hit that like button before you go, and thanks for watching.